Okay, Section 8, notes, Part 2. This is more with square root functions, only these are inequality graphs, but we're going to treat them exactly the same with the exception of, and I'm sure you remember by now, we get to shade these and put in the occasional dashed line. So off we go. The vertex, if you didn't watch Part 1 video, I will just go ahead and point out or remind you that square root functions all look like this. They start with a vertex. They work their way to the right in an arc like so. So imagine that's half of a U that's on its side. So the question is, what's the vertex, which is this guy? And for this problem, well, just like we were treating them before. Now that -2 is outside of the symbol. He's outside of the square root. So he's going to be my y coordinate. And what's inside with the x? Now it'd be tempting to write a 1, right? But the 1's in front of the x, which would be multiply. So I want to know what's being added or subtracted in there. And nothing's being added or subtracted inside of that square root symbol. So I get a 0, -2. Here's my first set of coordinates. And all graphs, keep in mind, can be done this way as far as getting more points. So XY chart, again, I like repeating my vertex number. And then you just need to work your way to the right, picking coordinates. So if I were to plug a 1 in for the x right here, I have the square root of 1, which is 1, and 1 minus 2 is -1. 1, -1. So we'd like to see a total of 4 points for these. And we're going to allow you 1 decimal. But I'm going to skip that for now, and I'm just going to go ahead and find myself one that comes out even. So if you watched Part 1 video, you would know that I can try any x coordinate I want. But if I plug a 2 in, the square root of 2 does not come out even. If I plug a 3 in, the square root of 3 does not come out even. So I'm not going to use those. And I'm just going to keep working my way up until I find one that does. Well, if I plug in the 4, square root of 4 is 2, comes out even, and 2 minus 2 is 0. So I can avoid using a decimal there. Yeah, it goes right there. So the question is, what's the next number that comes out even? Now, so I'm going to allow you to have, I want to have 4 sets of coordinates, and you can use 1 decimal. So you can use any number you want at this point. But I'm just going to say, hey, what number do we have to keep going to until we finally find one that comes out even? And if I were to use a 9, square root of 9 comes out even, that's 3. 3 minus 2 is 1. I don't think that fits on my graph, but we'll fudge it. 1, 2, 3, 4, 5, 6, 7, 8, 9, comma 1. Just a little bit off the edge there. All right, so before I draw this in, let's go back and check this out. Right here, I've got an equal to symbol underneath there, which means I'm not making a dashed line. I'm making a solid line, like so. And since that's a less than symbol, I'm going to shade below it. So the question is, do I want to use some highlighter? And I think I do. So shading. Now, one important thing that's different with these shades as opposed to most shades. Notice I did not go beyond the y-axis, and the reason for that is the graph itself does not go beyond the y-axis. So the last set of coordinates I graphed, or that first initial set, does not go beyond that guy. And if it doesn't go beyond that guy with the line, I don't want to go beyond that guy with the shade. All right, that's it. That's all it takes, guys. So, second graph. Establish a vertex. Now again, keep in mind that -2 out in front is being multiplied. It's got nothing to do with the vertex. So my number inside is a +4. I want to switch it. I see no number on the end. That counts as a 0. And I'm going to go with -4, 0. XY chart. Well, next number up is -3. If it doesn't work, I won't use it. But in this case, it'll come out even. -3 plus 4 is 1. The square root of 1 is 1. Times the -2 would be -2. -3, -2. So let me pause for a second here and ask you, what's different about this graph as opposed to the last one? And for that matter, some of the other ones we did on video part 1. Well, if this is the vertex, I am now working my way down from there. So why is that? Well, hey, there's a -2 out in front of that problem, and a -2 would give you negative values if you multiply, and therefore it's forcing the graph down. So it's just one way to check out, make sure that you're putting the dots in the right spot. All right, working my way up. If I go -2, that square root will not come out even. If I go -1, that square root will not come out even. If I go clear to 0, hey, it's going to come out even. So plug a 0 in there. 0 plus 4 is 4. The square root of 4 is 2. 2 times the -2 that's out in front is -4. So 0, -4. Now again, any set of coordinates will do right now. You can use a decimal if you'd like. But I am just going to keep working my way up until I find one that comes out even. So if I jump all the way up to 5, and I plug a 5 in here, 5 plus 4 is 9. Square root of 9 is 3. 3 times the -2 is -6. And I can avoid decimals there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And I've got the required 4 dots. So if you notice, I already started making a dashed line on this guy, and that's because this symbol does not have the equal sign underneath it. And we know that that makes a dashed line. So there's that arc. Granted, it's the underside of the arc this time, but nonetheless, a square root function arc. So greater than. Well, greater than means I'm going to shade above. But I do not need to go past, or should not go past, that spot right there, because the graph itself does not go past that. And remember, make the math teacher happy by drawing if you want. So there you go, guys. That's it for inequality graphs. The reason we are not going to ask you for domain and range on these is because the shaded region is an infinite number of answers. So if there's an infinite number of answers, domain and range really is completely unnecessary for these. All right, if you are questioning or having issues or questions about domain and range, please watch video 1 from this section. Thanks for watching.